Well, welcome back to the Azure Podcast. This is episode number 498, being recorded on the 26th of June, 2024, with special guest Delbert Murphy. I'm Sujit, and on Teams with me, we have Kale, and of course, our special guest Delbert, who we're going to get to in just a minute. But before that, let's cover a few updates that happened this past week in the Azure space. Kale, do you have some? I think you put something in there, right?
Yeah, I dropped one in there that's it's not directly like a service or anything in Azure, but it kind of helps our services inside of there. And I thought it was interesting technology. So this was something that was announced in one of our um, events here just recently. It was around the hollow core fiber. And the pitch around this is the hollow core fiber for accelerating AI. Pretty nice article about explaining, the technology behind, fiber and how we had solid core with glass, being used, and now we have this hollow core with air that can provide, faster throughput. And essentially, the article kind of goes through that, and obviously workloads like AI, where there's gargantuan amounts of data that have to be potentially moved around, is something that could benefit from this, as well as other things. I can imagine streaming videos and things like this, or some other ones. But it was super interesting tech around something that we kind of take for granted, as part of the infrastructure of how all this stuff works. But it was kind of neat to see that innovation in the fiber space.
Right. And this is available for customers to use now, or when is this going to be available?
That I'm not sure about. They didn't really talk about that in the article. It's definitely something that
They're kind of
Azure's
working
connected
on
with.
it.
Yeah, I believe
Okay.
it's something not long-term future. I think it's short-term future, but this stuff has been tested and things like that. It's not theory. I think it's more around like getting the cables laid, kind of thing. So.
Yeah, I think it just becomes part of the both new data center development, and then, for planned maintenance and things like that, as you're pulling cable, they're just going to use the new stuff. And
Right.
then, yeah, for the AI supercomputers, I'm sure that that's first in line, right? That those will get that for training the next OpenAI models, or the inferencing that we're doing on those models.
Right. That makes sense. Cool. Very cool. Thanks for that, Kale. So I have a few updates. There are two of them in the AKS space. Uh, you know, uh, Today, whenever you set up an AKS cluster, most customers would create the private AKS cluster, and for good reason. But the problem with the private cluster is that it's really tough to get like a kubectl connection on it. You have to be on the VNet, and you need to have a VPN and all that drama just to be able to do like a simple command, right? So they've now provided a feature in the AZAKS CLI where you can just put the kubectl command. So go run this command on the cluster for me and give me the results, right? And so just for anyone, you can do it from anywhere that you have AZAKS access from, and that'll go through the backdoor through it'll obviously check your RBAC permissions and everything, and then go through the VPN, through the VNet, private VNet, execute the command on the cluster and return the results back to you, right? So just for quick kubectl commands, I think this is a nice little feature. Just reduces the drama that the admin would have to go through otherwise. You'd have to do like a jump box and all that stuff to get access to that private cluster. So that is one feature on AKS that I thought was cool. Another one also related to AKS is, when you do some of these long-running operations in AKS, like, maybe you're setting up a new cluster, or you're adding a node, or you're scaling up, scaling down, making some of those changes that take a little bit of time because it has to go, node to node as it does that. Sometimes you don't know how far it's gotten, right? Whether it's finished half, 25%. Now there's a new again a new AZ command that you could use to it's AZ AKS operation, and you can say show me the latest operation. How much is it completed? And so it gives you like a little snapshot. Okay, it's this percent is completed. So at least the administrator feel like okay, it's not just stuck or something like that. It's kind of proceeding at some point. The old progress bar that we used to is available for these kind of long-term operations. So I think that's another nice feature in the AKS space. Third update, which I felt really passionate about, was with Service Bus, right? And you know that using Service Bus, one of the biggest things that you're concerned about is that the data, all the messages in Service Bus could get lost if, let's say, there was a complete region outage or a region meltdown, for example, right? You'd be down, your business would be down. So customers have typically had to do things like shipping the messages somewhere else to another region, and doing all of that coordination to prevent that from happening. Hopefully it never happens. Now they have a new feature which is in preview, which is Geo Replication. Now they had Geo Replication of the metadata there before. Now they've added the data as well. So it's a geo-replication of the metadata and the messages itself in another region. And if something were to go down, you can switch your kind of primary to the secondary region, and that all the applications will just work because it's the same URL that is being used. It's just swapped to the secondary region, and you have to you can initiate that yourself if you feel that there's a problem with the primary region. So I think this is, I've built systems that we wrote a lot of code to kind of to do this, making copies and then synchronizing to kind of message systems and whatnot. So I'm happy that that code is redundant now. It's a good thing. And finally, there's a quick update related to just traditional VMs. And what the problem is that the VMs can use data disk to zone redundant data disk, right? So we know that the data disks don't go down, but unfortunately the VMs, because of a regional problem, could go stop working, right? And the problem is when that happens, they're still somewhat attached to these disks, so they don't let go of the disks, and you can't really use that disk in another region. Typically, you want to take that good disk, right, from the bad VM and put it in another VM in another region, right, and now there's a new command that's available which will let you force detach the data disk from the VM. So, in case that VM's not behaving, you can say, okay, I'm going to just forcefully detach that data disk and just point it to the other VM which I'm going to spin up in the other good region, and you're back in business at that point in time. So this is something that's available if you use the traditional VMs for your workloads.
So for those of us who've been around like 20 years, that's like yanking an IDE cable off a hard drive. Like that's what that's like.
That's right, and then shipping it to the other data center in a FedEx truck or something. Yeah.
But
Yep.
I'm assuming you don't really worry about when you do that in a physical data center. You better hope they're quiesce you write operations. And
That's right. Yeah, you don't want to leave it like right in the middle of doing an update on the disk for sure. Cool. So that's all the updates. So yeah, Delbert, thanks again for joining us. Go ahead and introduce yourself to our listeners. Tell us what you do at Microsoft, what your passion is in the Azure space, and we'll take it from there.
Okay, cool. Yeah. So hello, everyone. My name's Delbert Murphy. I'm a cloud solution architect in the customer success area inside of Microsoft, formerly in Microsoft manufacturing. There we go. And I am also a founding member of the Azure Quantum Field Ambassador Program. So the program's been around inside of Microsoft for about 3-4 years now. And we have a set of dozens of folks scattered all over the world who are quantum computing enthusiasts, and we also have special contact with the quantum computing team to continue coordinate so that we can work with customers to get them either started with quantum or started with Azure Quantum Elements, which is our computational chemistry solution that's currently running in Azure. So we help with those things and let the quantum team concentrate on getting those Majorana fermions to dance around inside of the chip.
That's really great.
And my passion is around quantum physics and math. So yeah, in my spare time, I'm unifying quantum mechanics and general relativity.
Yeah, and I can see that, if I had a physics professor in my class, I can imagine you being my physics professor.
I might look like him. Yes, that some customers have nicknamed me the professor, and I hope it's not because I lecture them too much, but I think
Yeah.
sometimes I do.
So, we've had a couple of shows on quantum, going back over we've been around now for 13 years, the show. So
Mhm,
we've had at least two shows on quantum. Back in the early days when, we had to understand what was it, what a qubit is, or a
mhm, mhm,
qubit, I
mhm.
forget how the right way to say it.
Qubit,
Qubit,
yeah.
yeah. And what that was, and then later on, when it came to the katas, I remember,
Hmm.
learning how to program quantum and QSharp, and that was when I started playing around with QSharp, and I think I did about 4 or 5 of the katas. That's as far as I could get without the math becoming too confusing for me.
The quantum kata are now, we have a new version of the Q-sharp compiler and what's called quantum intermediate representation. So it's quantum bytecode, if you will, that directs the hardware on what to do. And then we have a new quantum simulator. Those are all written in Rust. They are all open source, and
Hmm.
they will run in your browser. It's just because Rust compiles to WASM, so you
I
can
see.
use the WebAssembly, and it just is smoking fast. It's incredibly responsive, and then the Q Sharp, over the years, we've enhanced the language, and really from the beginning, Q Sharp was intended to help you manage 1 million qubits. That's the design intent behind the language, rather than some of these other toolkits that, if you're using 5 or 10 qubits, it's okay. But once you get beyond that, you actually have to like use Python code to generate Python code to manage 100 qubits, let's say.
Wow.
And so it really gets your meta programming. Instead of in Q sharp, you're just naturally using the things that folks are used to. And for those who have video, here's a uh, a quantum circuit. And so those same things, like, a NOT gate or a Hadamard gate or anything like that, those just appear natively in Q sharp as operations. So it's a very natural way to implement the language. And so that's kind of what's new with the Q sharp world.
And
Yeah,
go ahead.
I was going to ask along with that. In the ecosystem of people building stuff, I assume a lot of this is early stage kind of things because quantum is, well, maybe it's further along than I think, but like, kind of early stage prototypes and POCs and things like that they're building. I guess my question is, like, we have a lot of the foundation, obviously the heavy back end to run the infrastructure to run this kind of stuff. And then we have things like these languages like Q Sharp, and we've talked about those on podcasts before. But like, what's it look like? You've worked with customers and things like that. Are they
Mhm.
using these kind of low-level tools? Are there partners in this ecosystem who are building on top of stuff we have there too? I'm not familiar with like how that ecosystem looks right now. While people are starting to build on this, like.
Yeah, yeah. So part of the Azure quantum ecosystem, and it gets a little confusing. Um, oh, gee, imagine that about Microsoft, right? Complicated. Um, the um, quantum computing, we host other quantum computing providers in Azure and make those available as basically endpoints you can program to. So instead of programming to an OpenAI large language model, you just program to this Quantinuum quantum computer. And yes, these are very early days, but using that Q-sharp, the QIR, and Quantinuum hardware, so trapped ion, 32 trapped ion qubits, we were able to demonstrate earlier this year 2 virtual qubits, and they are qubits that are 800 times more stable and more error-free than the underlying physical qubits. And that's the first time this has happened in the quantum computing world. So we're taking baby steps forward, but we're making them. We're going forward with them. And yes, there are some partners, many of whom are also auditors. So like Ernst and Young, and the other big audit firms are partnering with us to help folks analyze their risk for post-quantum cryptography. So that's kind of like one set of partners who are doing work. And then there are dozens and dozens and dozens of research organizations as a part of this Azure Quantum Network. So Oxo Nobel, Dow Chemical, just now Unilever. There are a whole bunch of folks involved in material science and chemistry who are part of this research network who are partnering with us. So it's a little bit more of that sort of a model right now than a strict, you get a partner like Crayon who helps you do data science and analytics, for example. It's not quite like that yet because the quantum field is still early. And then, but the other piece is we do have a SaaS solution that does computational chemistry using some super advanced both machine learning and high performance compute. So this is where that hollow core fiber, man, that'd be great to have with these high performance compute clusters. And so that does classical computing, but to simulate chemistry reactions and help find new materials, do material discovery. And with advances we've done with Quantinuum and with photonic, those advances are going to come into Azure Quantum Elements as soon as the advances have been kind of productionized, if you will, and that's been announced as part of the partnerships with those two companies.
Okay, you talked about quantum elements, right, as being part, and then this SaaS offering as being kind of another piece. And you think the two are eventually going to combine?
No, Azure Quantum Elements is the SaaS offering.
Okay.
That helps you do computational chemistry. So it's like in silico chemistry, maybe.
But it's not using the quantum computer yet, right?
Correct. It's using some very advanced stuff that comes from AI for science and so we made the announcement last week on this generative chemistry. So just like you have a large language model that predicts language tokens, we have a large molecule model that predicts molecules. And so if you're looking for a particular kind of material, and there are a lot of folks who are looking for more sustainable alternatives to put in all sorts of products, okay? So when they're looking for those materials, this large molecule model generates possibilities. And so you get a funnel of 10,000 different molecules that you can start screening your way through in Azure Quantum Elements until you get down to a handful. And then you can take those handful to the lab and try them out in the lab. So that's the idea, and it uses, Azure Compute. We use new stuff from, these large molecule models, if you will, are based on Graphomer, which is a Microsoft research project. And then we have DFT modules, or density functional theory, very special modules that help you compute how these chemical reactions might actually play out. And so those run in Azure as well.
Cool.
Well, one thing you mentioned there was around these audit firms and post-quantum cryptography kind of things. I hear that mentioned a lot, and maybe for our listeners, like, what does it mean post-quantum? Is there like a date? Like it's like, oh, January 3rd is post quantum. Like we're gonna, or is it like once we cross this one threshold? I assume that's what that means. Like once we cross this certain threshold, but there's only like a handful probably of service providers like Azure or others who can even run this stuff, right? So like, I guess how's that all play together, and what does that mean for like post quantum? What's that mean? Yeah.
So you can use an algorithm called Shor's algorithm on a quantum computer that's big enough. We don't have one that's big enough yet, but on a quantum computer that's big enough, you could use Shor's algorithm to decrypt HTTPS traffic. So there are a lot of nation state actors right now who are doing what we call store now, decrypt later. So these folks actually advertise routes on the internet, BGP routes, and say, yeah, CIA.gov, that's me. And they will take all the HTTPS traffic for CIA.gov and store it. And then they're going to decrypt it later when they get a quantum computer. And so government agencies have been aware of this for a while. And then from Microsoft, as part of our Secure Future initiative, right, that we're helping customers understand this and be able to put new algorithms in the place of the traditional HTTPS to be able to communicate, even if there's a quantum computer that's capable of, basically they'll be able to communicate, and a quantum computer will not be able to decrypt the traffic. So that's the idea behind that.
So I've heard one good use of this technology, which is, potentially the molecule model, which will come through quantum at some point. And then there's the not so good use of the model for decrypting HTTPS traffic. What are some of the other things that you're talking to customers about for where, a quantum, or even the quantum elements for that matter, could be leveraged, right? That technology. Like, what are some of the other use cases that customers should be thinking about when they say, "Oh, maybe we should think, call Delbert and see if he can help us with this thing,"
See what I mean, and there are a broad range of different things right now. Even something as simple as the vials that take samples, like a blood sample when you go for your annual physical. The vial actually that holds the sample that goes to the lab, there's actually an inner liner in that vial of a different kind of material, and that inner liner has to not interfere with the sample, right? It can't contaminate the sample. And so finding the right material to make that inner liner. The same thing for lining cans for food. There are folks developing special kinds of paint that you can that are for marine applications that absorb radar. And so that's a defense application, and finding the right things that go in that paint. Unilever, so they're a huge consumer products company. They actually touch 3.4 billion people every day. They're looking at a number of their products and using Azure Quantum Elements to come up with more sustainable formulations. So that is a big one. If you're a and I've seen it with food flavorings, I've seen it with fragrances, with cosmetics, things that you can possibly formulate in a more sustainable way. We have we have a workbench where you can do that in the cloud instead of having to do it in the lab.
And at what point should customers be thinking about, the Q shop world, right? Like, at what point should they be saying,
Quantum.
maybe I should do some of these katas and learn some quantum because it might be useful for this or for that. I guess I'm trying to understand what those scenarios would be.
Right. My advice is that the future is already here. It's just not uniformly distributed yet. So we're coming to a point very soon where quantum computers are going to be useful, and we're going to need people who can program those. And programming them, as you found, right, is different. It's a different way of thinking about things. So I would say that folks who are passionate about this area, about math, and maybe give the kata a try. You can just go to quantum.microsoft.com and try them out there in your browser. If it's something that interests you, I would say jump into it now and develop that skill. Because if you remember a few years back, everybody was scrambling trying to find data scientists. And because all of a sudden this machine learning stuff took off, and corporations were like, oh gee, I don't have anybody left. So I would say this is a good time to start learning this stuff, form a center of excellence, join a quantum meetup, start to learn those things. And then quantum computing is first going to be most useful in chemistry and material science because you're using qubits to simulate how electrons work in chemical reactions, right? And chemistry is all about those electrons. So that's going to be the first place. And then as we get more and more qubits that stay stable long enough to do the calculations, then anything that involves a huge number of combinations that you can still put the data, so it's relatively smaller data, that you can put the data in your quantum computer to compute those combinations, then that's going to be a great place for that. So I've got a warehouse with 50,000 packages in it, and I've got 49,000 customers who need, we need to get all these packages on trucks to go out to people to be delivered. Solving those kind of combinatorial problems are perfect for a quantum computer.
Sounds like it would align with the AI model, right? Because we have these prompts and like with a billion parameters feeding into them, like, wow, that seems like a marriage there a little bit, like.
Right. The graph former is a graph deep neural network model that uses transformers, just like large language models do. And yeah, those aspects of it are just incredible. And then when you look at, especially, they're called restricted Boltzmann machines, which is a special kind of neural network that Jeff Hinton developed back in the day. Training those is very much like programming a quantum computer. So there's some synergies there with machine learning that, again, as we get more and more qubits, those options will open up to us.
And but as we kind of wrap up over here, like, what is the time horizon, just roughly, we're looking at before these things are going to be, as you said, useful for consumer consumption, or for enterprises to consume?
It's really it's really hard to say. I think most like NIST, the National Institute of Standards and Technology, is looking at I would say maybe 5 to 10 years out still. But I think that especially when it comes to these, post-quantum cryptography algorithms and stuff like that, we have a program called Quantum Safe, and we're rolling on that. So I would say the and I think I tell customers that within the next year or two, I think we're going to see a Sputnik moment. We're going to see something that's a very dramatic jump in quantum capability, and then after that, it's just going to go nuts, I
Got it.
think. So yeah, so that's kind of the time horizons we're looking
Great. I'll dust off the katas and get back to it then.
at. Exactly.
Awesome. This has been great. Is there anything else that you feel you'd like to share with our listeners in this space? I think we've
No,
covered
I
pretty much
think,
everything.
yeah, I think we've pretty much covered everything, and it's really the Azure quantum elements and the chemistry and material science now, and then building towards more and more complex quantum computers over time. And we have some really terrific partnerships that are yielding, industry leading results. So it's stay tuned.
Thank you. Thanks a lot for coming on the show.
You're welcome.